This will be given by Alistair Ford from Newcastle University and will be followed by question and answer. The next presentation will be Supporting Cities in Assessing Costs of Climate Change, Prioritizing and Financing Adaptation by Hélia Costa from the London School of Economics, also followed by a short Q&A, and then we will wrap up the webinar. So for questions and comments, please write in the chat windows. You have two options. You can either post your questions to all panelists. Please make sure that you send it to all panelists. Otherwise, you can also post them in the Q&A. If you have any technical problems or issues and cannot hear us, please write my colleague Alberto Terenzi, and he will make sure to help you. So I will hand over now to Alberto Terenzi from ICLE to give us an overview of the RAMSES project.
Yes, good morning everybody, and welcome to the second RAMSES webinar also from my side. I'm just going to give you a brief introduction to the RAMSES project before then we dig deeper into the topics of the day. So first of all, I would like to explain why RAMSES has decided to have cities as its focus. So basically cities have a crucial role in the transition towards a more sustainable world and also in making sure that the places where a lot of people and assets reside are made resilient to the consequences of climate change. Cities are also the main emitters, so they're also one of the main causes of climate change, and for that they also have to take action to tackle that. And also cities are the places where a lot of assets reside, which means also that a lot of economic value is placed in cities, and this economic value has to be preserved by cities. So cities need then information to do that in order to understand what are the risks in the face of climate change and where these risks are placed in the urban texture in the different areas of the cities, and also they have to understand what to do. So RAMSES has taken a double approach in order to tackle this need. On the one hand, the project has carried out a top-down high-level climatic assessment that gives an indication of which cities will be affected by which impacts. So it gives more a macro-regional assessment of what the main challenges will be in terms of the effects of climate change. But on the other hand, as I said, cities need really bottom-up, detailed vulnerability assessments in order to understand really where the risks are placed locally. They need both because, of course, already having a high-level understanding of how the climate is going to change in a specific area can give them good information to start acting, and then as long as they proceed in their adaptation journey, they can need more detailed information. So basically, RAMSES has looked at different aspects that are part of planning a climate adaptation strategy. First of all, we have a part of the work that is about, as I said, understanding impacts and vulnerabilities. This encompasses vulnerability and risk assessments, both at a higher level and at a small scale, as I said, but also RAMSES developed a taxonomy of architecture and infrastructure indicators. Of course, architecture and infrastructure is the backbone of cities, and so it is important to understand how to make these resilient. Then a second part that the project has inquired into is about understanding the costs that are linked to climate change, the costs that are linked to adapting and to not adapting, and also the benefits that adapting produces in terms of avoided costs and created benefits. And one specific aspect that we looked into is also the costs that climate change causes on health, which are the health impacts caused by climate change, and also how to develop strategies to tackle these costs, especially in the face of heat waves. So which are the costs of heat waves, and how can cities develop a heat-held action plan that will make them stronger in the future in this regard. And then finally, we have looked at the broader picture because, of course, adaptation is a set of measures, but it is for and foremost a process. So basically, we looked at what is the political assessment, what are the conditions politically that can facilitate adaptation to be prioritized on the political agenda. So Work Package 8 has looked very much at how to create transitions from the current state to a more resilient future, and which pathways exist to reach a desired outcome. And then we've also looked at which are good governance constellations that can be created for adaptation. One approach that we have taken throughout the project is that of having a constant dialogue with stakeholders. We have organized 3 stakeholder dialogues in moments in which parts of the research of the project were being finalized, in order not only to present what had been done, but foremost also to get feedback from practitioners, because the research that is produced in RAMSES is meant to be useful to cities, to adaptation practitioners, and so we have had this dialogue, and it has helped a lot ensure that the results that we produce were in touch with the reality of climate adaptation planning. Just to give you a short kind of glimpse into some of the things I mentioned, this is the work that has been done on the high-level urban climate risk assessment. So basically, 571 cities have been analyzed, and their hazards have been combined with their exposure and vulnerability in order to understand what the risk is and which the risks are that affect cities in a particular area. I guess Alistair will elaborate on this, but the main message is that, of course, this information cannot be used for detailed climate adaptation planning, but still it gives a precise understanding of which hazards are the ones that maybe cities should look into more in depth when planning locally for adaptation. And then, as I said, this detail level of planning comes, and for example, for the cities of Antwerp and London, a high-resolution pluvial flood modeling has been developed in order really to see what the risks in these cities were, where they were placed in terms of neighborhoods, and also which strategies could be implemented in order to counteract those risks, and specifically. The work that RAMSES has done has focused on blue and green solutions to tackle these risks. I just wanted to show you this slide because this says a lot about the risks that cities are facing. So basically, with regards to heat waves, what RAMSES has found out is that from 2081 to 2100, the number of heat wave days is projected to increase by a factor of 10 to what it is now. So it's really huge risks that cities have to plan for in advance. This is another part of the project, and it's the part about costs that Hélia is going to elaborate more on. So I'm not going to go into details, but I just wanted to show you the rationale of the work that has been carried out, which is that of combining basically the negative effects of heat waves with the work productivity of a city. I mean, cities are, of course, hubs for many activities and sectors, and also depending on the structure of the work market in a city, the impacts that heat has on its territory are different. So the London School of Economics has really analyzed which kind of sectors are most affected by heat and which measures can help counteract that. This I mentioned before is about heat and health. And so it just shows you quickly the structure that is used by the tool that has been developed by the World Health Organization to develop heat health adaptation plans, and which are the variables that need to be taken into account to do so. So what I wanted to then come to quickly is the products that the RAMSES project has produced. Of course, on the one hand, if you go on the RAMSES website, you will find really a wealth of knowledge, reports and studies that will really give you a very thorough and detailed understanding of the issues that I've mentioned before. But as I said, RAMSES has as its scope that of supporting cities in their adaptation planning, further to that of developing, of course, sound and innovative science. And so what we've done in the project is that we have developed a set of tools that are specifically meant to support cities in their endeavors. One first output that we have is the handbook and training package. Basically, this document condenses all of the knowledge that has been produced in the project in a short and easy to read format, and proposes an implementation cycle for adaptation, which is based off the Urban Adaptation Support Tool, which is the official methodology used by the Covenant of Mayors for Climate and Energy Initiative to plan for adaptation action, and so gives advice to cities on how to use the knowledge produced in the project in order to start advancing on adaptation. So whereas the handbook gives a bit more of a theoretical framework and presents the results, the training package proposes activities that cities can do with stakeholders in order to take the steps that are necessary to develop an adaptation strategy. Another product that can be used in conjunction with the handbook is the RAMSES slide deck. This is basically a PowerPoint slide deck that summarizes the main results of the project, and that can be used by cities to communicate internally and externally about the issues related to climate change. So it can be just downloaded and tweaked to the needs of different cities and be used for presentations, for meetings. This is another support instrument that we wanted to give to cities in order to empower them to take ownership on an adaptation process. And last but not least, we've developed a audio-visual guidance. This is basically a collection of over 100 videos by climate adaptation experts of different sorts. There are scientists that are in the videos, but also city representatives, also adaptation practitioners of different sorts, regional governments, for example, that give advice on different issues that are crucial for climate adaptation. So they are short videos, and they can be used by anyone to show, for example, the evidence on a specific phenomenon, and to know more, to get to know more about a specific topic that the city is engaged with. So just to show you a bit how the transition handbook and training package are structured, as I said, they use the Urban Adaptation Support Tool methodology, and they, for each step of the methodology, give a bit of the a structure for each of the steps in order to go through the step and really progress on the step. As I said in the training package, then there are exercises that can be used to operationalize the steps that are presented in the handbook and make it into activities. So really, I think this tool can be really useful for adaptation planning, and I really invite you to download it and flick through it because you might find findings that can support your work. So with that, I would like to thank you and hand over to Serene again.
Thank you very much, Alberto, for this comprehensive presentation. And I would like now to give the floor to Alistair Ford from Newcastle University to give us his presentation on analyzing urban flood risk and adaptation options.
Thank you, Serene. Hopefully everybody can hear me okay. So my name is Alistair from Newcastle University in the UK, and I've been working as part of the RAMSES project on analysing urban flood risk and looking at how we can understand adaptation options to reduce risk in our cities. And as part of this, we've been using models and simulations of flooding and the impacts on different sectors. So we know that cities are already facing quite a large threat from climate change, but what we've been doing is trying to understand how adaptation fits into the other pressures that cities are already facing. So adaptation to climate change is one demand on city governments and decision makers through increased extremes in the future that we expect to see, but also general trends that might have effects like reduced water availability or even impacts on the food supply. But there are other pressures that are happening at the same time. The need to ensure infrastructure delivery to keep cities functioning, socio-demographic changes, so an aging population, etc. And when these two things work together, the socio-economic changes and the climate changes at the same time, we can see increases to the risks faced by cities from future climate change. So what we want to do is help decision makers consider the adaptation they need to make by thinking of cities as systems of interconnected parts. So the diagram in the bottom right shows how climate change and socioeconomic change may interact through different sectors in cities, and think about the trade-offs and co-benefits between those sectors and the interventions we might be able to make in cities, and do all of this in the context of mitigation. So we know that we still have to really pursue decarbonisation and reducing greenhouse gas emissions whilst making our cities more resilient. So quite a job. So the kinds of threats that cities are expected to face, Alberto touched on this, that we might expect to see quite a large increase in the number of heatwave days in our cities. We might also expect to see an increase in heavy rainfall events as the atmosphere warms and more water enters the atmosphere. And it's at these extreme ends of the distribution of events that we have less knowledge and understanding of what climate change will really bring. So we're trying to use models to understand the uncertainty in these events, but also understand the impacts of these kinds of increased rainfall type of events that we can see. So here are some photos from events we've seen in the past few years. And we expect these kinds of impacts to increase in the future. But how will they increase? Where will they increase? And where will they have the biggest impacts on the people who rely on, for example, the transport infrastructure to get around? So as Alberto said, in RAMSES we've come up with this transition model, and this, I think, Alberto or Suren will be able to confirm, but I think this was the subject of the last RAMSES webinar for those who are interested. But what we're looking at is these parts of the process of the adaptation transition process here, that the ability to assess risks and vulnerability that cities are facing under climate change from different hazards in different sectors, and then try to understand the adaptation options available to them, and maybe going into step 4, which is to assess the effectiveness of those adaptation options too. So in the IPCC, they use this diagram here to explain climate risk. So we have, as I mentioned earlier, the change in climate producing increased temperatures and therefore increased extreme events. But we also have socioeconomic processes which change what's known as vulnerability and exposure. So the climate change changes the hazard part of risk, so increased flooding or increased heat waves. But the vulnerability and exposure parts of the risk are driven by the socioeconomic changes that are happening in our cities, and it's how these things interact together that will help us to understand the changing risk from climate change. So what we're trying to do is use models of both climate hazards, so things like floods, which we'll talk about in this presentation, and socioeconomic processes, so things like transport or housing or land use change, to see how these interconnected changes will affect the risk in our cities. So as an example of the kinds of climate impacts you might expect to see on our infrastructure, this is an event that happened here in Newcastle a few years ago, where we had a heavy rainfall event, about a 1 in 100 year event, although measures like 1 in 100 years are becoming a bit less reliable, given that the climate is not stationary. But anyway, we had extremely heavy rainfall, and you can see in the picture on the top left that the roads in the city flooded as a result. There's probably 0.5 meter of water there as a result of this 1 hour event. But the disruption to transport lasted much longer after this. The disruption to the functioning of the city, the ability of people to get around the city and to conduct business, etc., was reduced for a number of hours. So the graph on the slide shows in the kind of turquoisey green-blue colour the normal traffic levels at a point in the transport network during the day, and the yellow line shows what happened to the traffic levels on that particular day. So you can see the traffic really kind of dropped considerably and then took a long time to clear after the event. And what we want to know is why that happens, were there particular points in the transport system that were vulnerable to flooding in this case, and were there, what are the adaptation options that we could use to stop this happening in the future, or at least reduce the impact. So again, to go back to what I said earlier, this is one sector with one threat, but there are many sectors in the city which are interconnected, and the adaptation options that we might have for this particular threat might also be able to assist us with other climate hazards, reducing the risks from those. And the adaptation options might not be restricted to, for example, just transport networks. We might be able to do things with land use planning, or the economic system in the city to make these kinds of impacts lower in the future. When we're considering impacts, there are direct and indirect impacts. So again, if we think of the transport example, that's what we could be looking at in RAMSES, there are direct impacts. So obviously, when floods or severe weather events happen, we see damage to infrastructure, and that obviously causes costs to repair that damage and the loss of function of that damage. But then there are indirect effects that are more due to the loss of function of the infrastructure. So it's not the cost to replace the actual damaged road or bridge, but the economy of the city suffers as a result of a reduced function of infrastructure. So in this case, transport. When floods happen, transport is particularly badly exposed because a large proportion of urban areas are made up with roads. And when it rains, those roads are sealed surfaces, so the water, if the drainage network can't cope with the volume of water, the water has nowhere to go, and we end up with floods. So thinking about flooding and transport, if we go back to the IPCC approach, we have hazard, which is in this case a model that we use here of flooding, which allows us to simulate the flow of water across an urban area and understand at any point during a rainfall event how deep the water may be in certain parts of the city, given certain land use characteristics. So how much green space there is in that city, how many green roofs there are, and what the topography of the city is. Once that hazard has appeared, we then need to understand what assets and people are exposed to the hazard. So if the hazard happens in an area where there are no infrastructure assets or no people or no things of value, then we may not be so worried about it as if that hazard impacts on particularly key pieces of infrastructure or areas where there are lots of people. And then the exposure part of the story that we've developed here, a curve that can link together the depth of water with the function of the infrastructure. So we can say as the water depth increases, the ability of a road, for example, or a railway to transport people is reduced. As fewer people can drive through the road when it's flooded. And by putting these three components together, we can start to understand the risk to transport across our urban areas and how we might start to adapt to reduce that risk. Ooh. Sorry. I've got a video here, but I don't know if I can play the video, so maybe I can skip over that video. Just to show that we've tried to understand how good these models are. One of the problems that we have in cities is we don't know whether the models we use are particularly accurate, especially with something like climate change. There's a lot of uncertainty both in the drivers of climate change, so the amount by which extreme rainfall might increase in the future, and how that rainfall might arrive, whether it's in large, short duration storms or longer, prolonged events. But we've been trying to, and there's also uncertainty, in how accurate the models that we use to then understand the impacts of that rainfall on the urban area are. So we've been trying to validate our models with observed events. So here are some photographs showing actual flooding and the modeled locations that correspond to each of these photographs, and we're fairly confident that this kind of model can actually capture, with the proper kind of parameterization and the right data, we can capture the kind of flooding we might expect to see in the future. And then how do we identify the risks from this? Well, as I said, we have this curve that links the depth of water to how well different parts of the transport infrastructure might function. And if we put that together with knowledge of the number of people who use parts of the infrastructure, we can start to identify hotspots. So we can say, well, if there's deep water on a particular road, so the bottom right kind of table here is a matrix that we can use. So if there's lots of cars using a road or lots of people traveling along a road every hour and lots of water present on that road, then it's probably a piece of infrastructure that we should think about and examine. So we start to create the kinds of maps that you see in the top right. So for different rainfall events and different adaptation options, we can start to see which links in the network might be at risk from extreme flooding. And then once we know where those links are, we can use that to maybe target our resources and think, how might we adapt to reduce those risks in the context of the wider city system. So we can do this with knowledge of how many people might be using particular links in the network. And again, we have a model that estimates which roads people might use to get to work or to the things they need to do. And that allows us to understand which parts of the transport network are particularly important. So once we understand the risks, then we have to think about how we intervene to reduce those risks. So this is where the adaptation part comes in. And there are different points in the system that we can intervene. So it's quite a complex diagram, but if you just focus on the kind of center column that goes from extreme rainfall to a flood, to some impact on the transport network, and then to some disruption to the use of that network, what we can do is intervene at different places. So we can think about green adaptation, so things like sustainable urban drainage systems, or urban green space in general, or better spatial planning options to reduce impermeable surfaces, as an intervention between the rainfall and the flooding itself. So we can try and reduce the flooding before it becomes a problem by using adaptation to capture the rainwater and hold it back from reaching the infrastructure. Another option might be to try and defend the infrastructure itself. So if we can't stop the water from getting to it, which we won't always be able to do, then we can try to think about, well, when the water does reach the infrastructure of importance, how do we protect that infrastructure? So we can intervene by improving the drainage network, which again may reduce the floodwater depths, stormwater tanks, or better larger drainage pipes. Obviously, these are expensive options. Might reduce the flooding, or changing the location of the transport network. So if we know that a key particular link in the transport network is at risk from flooding, maybe we need to think about changing the way the transport system operates to move that link out of danger or reduce the importance of that link. Another alternative is to adapt the way that the network is used. So rather than thinking about physically changing the network and the infrastructure, we could think about the operation and the management of that infrastructure. So things like soft adaptation. Can we use planning to reduce the reliance on the road network, to encourage more people to use public transport, which may be less at risk from flooding, especially kind of underground metro systems if they're protected from rainwater entering them, or use walking and cycling more than driving. Walking and cycling are generally more resilient to flood events. For example, people tend to find a way home, whereas people in cars tend to get trapped in floods much more easily. And this is where the story of co-benefits and mitigation come back in. So some of these options, be they in green adaptation, grey adaptation, or soft adaptation, may have benefits to reduce CO2 emissions. They may have benefits in other climate hazards, so reducing heat wave risk, etc. Or they may have benefits in things like biodiversity or quality of life. So by using models, we could start to understand what the effectiveness is in this particular hazard. But the greater knowledge of the city also allows us to decide which of these options might be better in other ways too. So again, we could kind of use these models to target where we build this adaptation, so we can start to put adaptations in the model and see what effect they have, and compare the effectiveness of grey versus green versus soft adaptation, and whether we build this adaptation at the transport link itself or upstream, so that we catch the water before it reaches the infrastructure that's important, or whether it's better to have dispersed or green space, for example, throughout the city. And then we can start to think, and Hélia will touch on this a bit more in the next presentation, about the costs and benefits of this, and how we deal with uncertainty. So there's a publication there where we've been thinking about a few of these things, if anyone wants to look at that later. So we've done this in London, where we've been mapping the flooding for the whole of the Greater London Authority area, and mapping the risk from flooding to links in the transport network, and calculating potential speed disruption for a given rainfall event, and using different land use scenarios to try and test what the effect of increased green space or roof storage, so green roofs or blue roofs, might be on reducing this flood risk. We've also been doing this in Antwerp, where we've also been looking at the underground drainage network, so how the drainage network might be used. So this is the kind of grey adaptation option. So the picture in the top right shows the underground drainage network and how that interacts with the surface water. One thing we've also been doing in Antwerp, at the top left, is looking at spatial rainfall zones. So each catchment, micro-catchment within the city, has its own rainfall simulation. We can see how storms might move across the city and water might interact in different ways. And again, I can't play that video, I don't think. That's a video of what Antwerp looks like when it's flooding, as an example. But maybe if we can distribute the slides somehow, people can have a watch of that. So once these impacts happen, we know that certain roads or railway network components in the city might be flooded. What we're then thinking about is how do we calculate the impacts of that. So the direct impacts that I mentioned earlier, where there's damage to infrastructure, but there are also a large number of indirect impacts. So if the road network's functionality is reduced, then we might see delays to travellers. We might see people arriving late for work or not getting to work at all. So the top left is where the finance sector jobs in London are. It's a very important sector in London at the moment, until Brexit, of course. But this is where the jobs are currently. And then the green lines in the centre diagram are where people travel from to get to those jobs. So you can see that people travel from all over the city. In the bottom right is the transport network that enables that. And if that transport network's functionality is reduced, then we can see impacts on the economy. And what we start to see is that, for example, the City of London has 162,000 jobs in the finance sector, and 47 of those commute by whichever mode this is. I think this is the road mode, the rail mode. And then what we can do is, for a given flood event, is calculate the total delay. So PMD is people minute delay for a given event. So that's how many people are delayed by how many minutes getting to work, and what percentage of the economic output of that particular part of the city is lost during this flood event. And knowing some numbers about what the GVA is for that part of the city, we can start to calculate the cost. And for example, that might, for one flood event, that might cost £9.5 million in lost revenue. And this allows us to then quantify the effects of these floods, and allows us to do a kind of cost-benefit analysis of what an adaptation option might help us with. And one thing we have to bear in mind is that there are first-order losses, so that people will not be able to get to work, but then there are second-order losses, which are the then knock-on impacts through the economy of one economic sector no longer being able to provide services to the next economic sector. And what we're trying to think about is how we can say, well, what is the cost of an intervention under different climate scenarios, and how these interventions stack up. So we might have different scenarios, A, B, C, D, E, which are protecting different parts of the transport network. And as we spend more money to protect more and more links, we might see that the benefits increase or at some point flatten off. And that's what we need to start understanding. So there's a publication here which includes some of these results of looking at the cost of interventions, the net present value of the benefits of those interventions in terms of reducing losses, and then how long it might take for those benefits to exceed the investment that we've made. So this allows us to start thinking about how much adaptation costs and how we can start to finance these things in different ways. So flood prevention might have different cost-benefit ratios to, for example, transport developments. So we might be able to adapt in different ways without having to spend on flood prevention. We might be able to change the way the transport system works and see co-benefits in doing that. So that's a whistle-stop through the kinds of modelling we've been doing in RAMSES. The results from all of this will be in the last deliverable from the work package that we're running here at Newcastle. So before the end of the project, you'll be able to see more detailed results for all of these examples that I've shown. But I hope that's been of interest and useful to you all. Thanks for listening.
Thank you very much, Alistair, for this presentation. And we will now take a round of questions. So feel free to type in your questions as mentioned, and we already have one. So I think this one goes to Alberto. There are many guidebooks on adaptation out there. Each project develops its own. So what do you think makes your guidebook distinctive? Alberto, would you like to take this?
Sure, I'm happy to do so. Well, I think that there are two aspects to this question. One is that RAMSES, as we said, is a project, a 5-year project actually, that developed unique knowledge on climate adaptation that was not available as such before the project. So the RAMSES Handbook encompasses this knowledge and uses it then as the fundamental knowledge to develop an adaptation pathway, and this is the only handbook that does that because it's very specific to the project. On the other hand, I think that we are also taking a different approach, so we don't want our transition handbook and training package to be considered as the only resource that can be used for planning for climate adaptation, and in fact we have planned the handbook and training package already when designing them as a resource that would naturally fit into the climateadapt.eu platform, which is the platform developed by the European Environment Agency and that is used also by the Covenant of Mayors for Climate and Energy initiative to support cities in developing climate and energy plans. So the handbook is already to be found there, together with other resources that provide information on different aspects on climate adaptation. So we have planned these exactly in order to avoid that this would remain a standalone resource that then would potentially be forgotten. So it has some features that are unique and that you can only find there, but it is also meant to be part of a library of handbooks and guidelines that cities can choose from and use for their adaptation planning.
Thank you very much, Alberto, for your answer. And since you do not have any further questions, we will proceed to the next presentation.
Sorry, Serene, just say that I see that another question has come in just now. So it is about the costs and benefits of adaptation. And I think this question we can take later because after Hélia's presentation, it might be a good point to tackle it.
Okay, thank you very much, Alberto. Hélia, please feel free to proceed now with your presentation.
Hello?
Hello?
Oh, hi. Sorry. I just
hi.
want to make sure you could hear me.
Yes.
Hi. Thanks, Serena, and welcome everybody. Thank you for participating in this RAMSES webinar. As Serena said, I'm Hélia Costa from the London School of Economics, and today I'm going to give you an overview of the latest work that LSE has done for the RAMSES project, which is directed at supporting cities in assessing costs of climate change, prioritizing and financing adaptation. More specifically, we developed a cost assessment framework for costing climate change, for evaluating adaptation, and for financing adaptation. So this is part of Work Package 5, which aims at assessing costs of climate change and cost of benefits of adaptation in cities, prioritizing adaptation based on the economic effectiveness, and evaluating policy options for raising and financing adaptation and co-benefits. And the cost assessment framework in particular has 3 phases that define a procedure for assessing risks and vulnerability based on damage costs, identifying and assessing adaptation options based on their economic net benefits, and planning and implementing city investments based on a range of financing mechanisms. So the idea why we wanted to develop this cost assessment framework is because developing more climate resilient cities is becoming a greater priority for governments and businesses. And increasing investment flows for adaptation is, of course, one of the major financing challenge. In order to use very limited public finance resources and to mobilize private finance effectively, city governments need to find appropriate processes and resources for investment planning and execution. And despite this, most cities lack the tools for performing economic assessment of damages, for evaluating adaptation, and for assessing financing options. Part of the difficulty in performing these cost and benefit assessments for climate impacts and adaptation relates to factors like uncertainty, for example, related to the timing and severity of climate change, related to the assets, to the systems, to the people who will be exposed to the climate events, the scale of the damages and the prices to mitigate against damage and to restore or rehabilitate, to factors of difficulties in measuring timing, in measuring effectiveness, lack of data, lack of technical capacity. So here you have an image which is called the cascade of uncertainty, which aims at showing how there is uncertainty in all the parts of the processes in measuring damages of climate change, in measuring adaptation, and how that means that within each phase, uncertainty extends even more. So there is uncertainty regarding environmental scenarios, and then there is uncertainty on climate models and on engineering models, so uncertainty becomes even larger. Then there is uncertainty on economic and demographic scenarios. This makes it even larger. There is uncertainty related to economic models. That makes it even larger. Then if you think about adaptation options, there is more uncertainty there, and there's even more uncertainty about how to finance these adaptation options. So the cost assessment framework aims to provide decision makers with a better guidance on the right tools and the right processes through which they can prepare more cost-effective adaptation strategies, given these inherent information limitations. So here you have an image that summarizes the cost assessment framework. So this cost assessment framework that we developed follows a hierarchical approach for prioritizing and financing adaptation. We create a comprehensive process for dealing with adaptation decision-making that will include social, political, technical, environmental, economic, and other considerations. The cost assessment framework is designed to support the RAMSES transition handbook that Alberto talked about and introduced in the first part, which lays out an encompassing process for making adaptation decisions. So more specifically, this cost assessment framework is designed to provide much of the economic and financial assessment needed for adaptation decision making, while abstracting from other types of decisions that are related to the process. So the idea is that we focus here more specifically on the issues related with measuring economic costs of damages, economic costs of adaptation, and financing decisions, the issues, the problems related to them, and how cities can adapt their own strategies in order to deal with within their own needs and within their own capacity, what kind of methods, what kind of processes they can use, such that they can make these economic decisions more favorably. So the cost assessment framework is divided into 3 key iterative phases that correspond also to the phases of the RAMSES handbook. And they follow a hierarchical process across these 4 levels that you see here. The first level connects the cost assessment framework to the RAMSES Transition Handbook. The second level specifies which costs are going to be quantified. The third level provides cost assessment methods and financing mechanisms. And finally, the fourth level lays out a range of inputs that are necessary to perform this economic analysis. The three phases then define a procedure for first, assessing risks and vulnerability based on damage costs. Second, identifying and assessing adaptation options based on their economic net benefits. And third, for planning and implementing city investments. So the first phase, I'm going to give you an overview, and the first phase is related to measuring climate change damage costs. As I said, there are 4 levels, and we actually go from the bottom up. So we have in level 4 the inputs necessary. We describe water hazards and exposure, how to measure vulnerability, and how to assess risk and uncertainty. As Alistair explained before, these are 3 key factors that are necessary. Then we go on to describe which methods and mechanisms exist and which can be more or less useful in each of the different city scenarios. And then we describe what actually costs we can quantify with each of these methods. And then, of course, this is what is necessary to assess risk and vulnerability. Just to give you an example, in this table, we have a summary of what we describe in the methods section of the cost assessment framework, where we describe some of the methods that are available for measuring damage costs of climate change. We divide these methods into 4 main categories: integrated assessment models, empirical or econometric analysis, science-first approaches, and economy-wide simulation models. Within each of these, we assess what is the best use for each of these models, what are their key limitations, what would you want to ideally have, would you want to measure all your direct and indirect costs, which methods are more or less suitable for measuring both direct and indirect costs, for measuring market costs, which ones you can use for measuring non-market costs. Then we go on to describe a few of the types, and we give examples of studies in which they were used. Then in the second phase of the cost assessment framework, we focus on measuring economic benefits of adaptation. So again, this phase is designed through 4 levels. As you can see, there are connections between this phase and the other 2 phases because, of course, the damage costs are going to feed into this phase, and the results of this phase are also going to feed into the financing phase, because only after you assess what kind of adaptation you would need can you go on to evaluate what kind of financing instruments you might need. So again, this is designed into 4 levels, starting from the bottom up, where we describe adaptation measures and what types of costs we might need to assess, and we introduce the concepts of timing and discount rates. We then describe some methods and mechanisms that exist to measure adaptation costs and benefits, so net benefits. We identify what kind of quantification of economic benefits we might need, and then we, of course, assess how this fits into this overarching RAMSES handbook, transition handbook. Again, to give you an example, on the method section on measuring costs and benefits of adaptation, we describe some of the methods that exist for measuring costs and benefits of adaptation, and we divide them into 4 categories. Again, we talk about the methods that are also used to measure damage costs, so they measure costs and benefits together. Within these, we talk about, again, integrated assessment models, empirical analysis, science-first approach, and economy-wide simulation models. We have the traditional economic decision support tools like cost-benefit analysis, adaptation cost curves, cost-effective analysis, and multi-criteria analysis. We have uncertainty framing with iterative risk management, and we have tools for economic decision making under uncertainty, where we talk about real option analysis and other decision tools like robust decision making and portfolio analysis. So for each of these, we assess a little bit, we explain the methods, and we try to assess a little bit of in which cases, they would be more or less effective in order to measure the types of costs and the types of benefits that can be more or less useful for each type of for each approach that each city might have. Finally, we focus on city investment in adaptation, because so what? We understand what the damage costs of climate events are. We understand what the adaptation needs might be, and then cities say, so what? This usually requires very large investments, and most cities often don't have the capacity to make these very large investments in adaptation. So in this final phase, we start by identifying sources of finance and finance mechanisms that allow cities to make investments such that they can implement their adaptation. This is a very important question because both the Paris Climate Change Accord and the UN Sustainable Development Goals have shown that there is a need for a more strategic approach in investing in public infrastructure that leverages both private and institutional capital more effectively. If infrastructure is going to be delivered at a local level, then decentralized levels of government need to be provided with resources, ideally with revenues matching their expenditure needs. And this is all the more important in the case of large public investment. For example, if we talk about a seawall, which remains mostly a responsibility of the public sector. So the World Economic Forum estimated that there is a very large infrastructure gap, that the deficit in investment for global infrastructure is growing above $1 trillion annually, and they estimate that an additional $0.7 trillion per year is going to be needed to move from business as usual economy to a green growth. So there is a need for a strategic approach to investment in public infrastructure that leverages the private and institutional capital more effectively. In our work, we identify some of the main barriers for financing adaptation at the local level, so specifically at the city level. The first one is lack of upfront capital, because governments lack borrowing capacity due to creditworthiness, because they lack a mandate to implement local taxes, so it means that very often they don't have the upfront capital that is necessary to fund its investment priorities. There is a second one, which is institutional inertia. And this is because usually in cities there are built up networks in financial institutions that favor deal making with known participants and with well understood technologies, so it's very difficult to move to different types of financing instruments. The third one is that there is lack of institutional capacity, there is lack of knowledge, there is lack of skills about, for example, financing mechanisms, accounting or budgeting, and this lack of planning and collaboration at very different levels. The fourth one is risk. So these types of investments are often perceived to have a very significant risk. So asset performance uncertainties, specifically for new adaptation that is less adaptation infrastructure, there is less well known. These types of investments have very large uncertainties, and there is also often regulatory uncertainties. The fifth one is that there are low returns. So investors forecast that this investment in adaptation will have low returns. There is lack of standardization in project development assessment for these types of investments. And finally, the last one is that there is often imperfect information. So there is a lot of market data, specifically at the city level, at the urban level, that makes these types of investments much more uncertain. So we develop a framework where we use these barriers, and we identify from a literature review, we identify 72 major finance instruments and funding models, and of these we identify 8 key finance instruments and government enablers that have significant potential to overcome these barriers. We group these investments into 3 main categories. So instruments to raise finance, so to help municipalities raise finance for urban adaptation, steering finance, so the ones that also steer behavior into more climate-friendly behavior, and blending finance, so instruments that aim at blending public and private finance. From this, we identify, as I said, 8 key finance instruments. So fiscal decentralization, bonds and debt financing, and the IFI finance. From this, IFI finance is is seen as possibly having a lot of financing potential at the local level. So these are institutions that provide financing and professional advising for the purpose of development. An example of these are multilateral development banks. So these are institutions that provide financing and professional advising for the purpose of development. They have the form of long-term loans at market rates or very long-term loans below market rates, and sometimes grants. And of these, the European Investment Bank is an example of these. Actually, the European Investment Bank has started to have an urban agenda and an agenda directed at environmental investments. Other instruments are land value capture, pricing regulation standards, national investment vehicles, and international finance facilities, which are very interrelated, and finally, public-private partnerships. So just to give you an example of the kind of work that we do, for some of these instruments, we identify some of the key challenges, and then we identify some of the success determinants that cities can have in order to make these instruments successful in raising finance for adaptation. So, for example, in terms of bonds and debt financing, a key challenge is the lack of municipal and credit worthiness. So we know that only around 4% of the 500 largest cities in developing countries are classified as credit worthy in the international finance markets, and even only 20% are credit worthy in even local markets. So some of the success determinants are the quality of financial management system, quality of urban governments, type of expenditure to be financed, and of course, national credit rating. Just to give you an idea of how much the city credit worthiness is related to the national credit worthiness, we have in this graph national credit rating plotted against city credit rating. And you see that they are very positively related. So even when cities are actually have a credit rating, it is often not a very good credit rating because of the national level credit rating, and so it makes financing through bonds very difficult. In terms of pricing and regulation, one of the key challenges is leakage and unintended behaviors from poorly planned price signals. So some success determinants are high level of coordination between national and decentralized levels of government. And finally, in terms of public-private partnerships, there can be poor policy and business environments that make it very difficult to extract the profit that could result from a given instrument, and so it deters private investment. So it's necessary to create appropriate project identification, contractual arrangements, and maybe centralized PPP units. So this was just to give you an overview of the full process. We describe a full process from on the economic side of costing and assessing adaptation options, starting from measuring damage costs to identifying effective adaptation options and identifying finance instruments. And of course, this is an iterative process. We need to go back and forth between these phases in order to understand and in order to tailor your adaptation processes to your city's adaptation needs.
Thank you very much, Hélia, for this lovely presentation. We now have the following question for the panelists. So, when assessing the costs of adaptation versus the benefits, does the training material account for the valuation of co-benefits? Health was mentioned, but I'm curious as to how the training material addresses this when assessing cost-benefits.
Yes, I can start answering this question if you want. So there are two aspects. One aspect is that the training material assesses for that, especially in the description of the phases. So the phase 4 of the handbook, which is the phase dedicated to assessing and selecting adaptation options, gives an overview of the evaluation criteria that should be taken into account when assessing options. And it states that these should be environmental, economic, social, and institutional. So the approach that the handbook takes in the evaluation of the options already naturally takes into account the co-benefits that arise from these options. More specifically, there is a table on page 104 to 108 of the handbook and training package, which accounts for the core dimensions of resilient systems in which their characteristics and benefits are for urban quality, and one of the core dimensions is exactly co-benefits. So there you will also find a description of which the co-benefits of, for example, grey infrastructure are, of green and blue infrastructures, and of other types of adaptation measures. So we've tried to make these explicit so that then when cities plan for measures, they are aware of which positive implications a measure can have.
Thank you very much, Alberto. Hélia, would you like to add something, maybe?
No, I think Alberto actually touched all the points that I wanted to touch on.
But then I have sorry.
Sorry, if I could just chip in there. Yeah. I think I mentioned this, the systems approach. So trying to think about how cities work, not in individual sectors as silos, but how they work as a kind of interconnected system. And I think this is another way of ensuring that we think about co-benefits in the anything we do in one sector will have impacts on other sectors. So again, with the transport example, if we don't plan our transport system properly when we are thinking about resilience, we may exacerbate other problems like CO2 emissions, but also air pollution, which can then have knock-on effects on the health sector. So it's important to try and bring together people from different sectors across city governance to make sure that we're talking to each other and that all of these co-benefits and possible negative trade-offs are considered as well.
Yes, thank you very much, Alistair. We have another question, which is, as indicated by Hélia, cities in particularly from developing countries lack capacity to access and manage finance and investment. What do you suggest to lower this barrier?
Well, you should really read our deliverable. So yeah, as I said, so we identify these types of financing mechanisms, but we also identify and connect them to specific barriers. So that when you're thinking about a specific city or a specific context, you can identify which barriers are more important to you, and then we have some of the determinants that would make some of these instruments more successful. So for example, if we're thinking about developing countries, as I said, debt financing, the financing through debt and bonds might not be possible because there's either a lack of credit rating or lack of credit worthiness. And so many times in these cases, it's international finance institutions that come in and provide the financing and the professional advising that will enable these types of cities to invest in adaptation options. Also because these institutions don't provide just the financing, but they also provide as I said, professional advising. So it would also increase the knowledge and the local knowledge that will also be useful in the future. That these cities can also use this knowledge in the future, because there are other types of. Sometimes it depends on the institutional setting in the countries that you mean, but it could be that it's easy to implement pricing and regulation and standardization. But it might be that that it's very difficult to implement these instruments, or that it's very difficult to provide decentralization because at the decentralized level you don't have you don't have a lot of technical capacity, for example, to provide to adjust your financing to your expenditure needs. So it depends a lot on the context of the country, which is why we try to provide not only the financing tools, but also pros and cons and which contexts they might be more or less appropriate for, what would be the key barriers, and some ways of overcoming these barriers.
Thank you very much, Hélia, and I want to thank all our panelists today, and conclude the webinar now since we have no further questions. So Ramses, what's coming next? So we have one more final training webinar in this final series. This will take place in early September with our partners from WHO and Technalia, and will be on protecting public health from climate change and designing pathways towards more resilient cities. We also have our Ramses final conference, which will take place in September 2017 in Potsdam, Germany, and is called Cities and Climate Conference 2017. So feel free to register. The contacts are in this slide. And please feel free to stay in touch and subscribe to our Ramses newsletter. Thank you very much for being here with us today. Thank you again to Alberto, Alistair, and Hélia, and to all of you, and have a good day.